Your preparation may look complete, but UPSC Prelims 2026 showed something important. Completion is not the same as readiness. The paper did not just test whether aspirant had read a topic, it tested whether they could think through it. Could they eliminate smartly? Could they connect static concepts with current issues? Could they stay calm when the question was not direct? Could they take decisions under pressure? That is where many aspirants struggle, not because they did not study, but because their preparation stayed in input mode, reading more, collecting more, revising passively. UPSC needs more than that. It needs a preparation system that turns knowledge into judgment. That is what the VisionIAS Delhi GS Foundation course is built for. Concepts are taught in a connected sequence. Current affairs is linked with static subjects. Tests help you identify gaps before the exam does. Answer writing builds structured thinking for mains. Mentorship helps correct your direction early. Build readiness from the beginning. VisionIAS Delhi GS Foundation course.
Afternoon. So in the previous session, which I think I took last week, I was talking about how to write good answers in paper 2. And the reference point for me is the 2025 paper, which was asked by UPSC last year mains examination. Okay, so I was discussing the answer of Section A in the previous session. In fact, even in Section A, I left that question number 4. So I told you few things in the previous session. I'm going to revise that. The paper 2, relatively, it's shorter in terms of the content, and the reason is that it is new for you. Paper 1 will take more time, and uska karan ye hai that paper 1 already aapne school mein padha hai, colleges mein padha hai, so that is why they build upon what you already have studied. In paper 2, many topics are introduced for the first time, so they have kept that scope limited. Otherwise, paper 2 also could have become a giant topic. So even when I take classes, I complete paper 2 in less number of classes. I take more number of classes in paper 1. And paper 2 generally is, because of that, also more scoring. And you'll find that people who are, let's say, scoring 320, they're getting some 170, 165 in paper 2, or 150, 155 in paper 1. But I do think that even in paper 1 you can score 125, 130. Anyways, sorry, total number can be 340 above. So in the previous class, I talked about that if I have to attempt few questions in this, among the 8 questions, maybe I will choose question number, maybe I will not choose, let's say, question number 2, because in question number 2 there are 2 questions which were asked by UPSC, which if you have not done before, maybe immediately at that point of time, you will not be able to grasp it. Although they both are easy, aisa nahi ki kuch bahut difficult hai. So this question was about, we learn about density of state, but this question is very specific to density of state if the particle has enough energy where the relativistic effect cannot be ignored. And then generally if you ignore that relativistic effect, you calculate density of state, it comes out to be e to the power 1 by 2 in case of 3 dimension. But here it comes out to be e square. So you just have to remember that how energy changes in case of, if we are not ignoring relativistic effect. But let's say that you're not very confident about this. So the second question hai, that was Dirac delta potential, which frankly they should not have asked because your syllabus mein de nahi rakha hai. If you look at your syllabus, it's very clear about that which of the potentials you have to know. Schrodinger equation, one-dimensional infinite potential, then finite potential, one dimension, then rectangular barrier, step potential, hydrogen atom, angular momentum. It does not anywhere tell you that you also have to know Dirac delta potential, but they ask this question. So it's not very difficult. I discussed this question in the last class, but let's say I will not attempt this, that because there are two questions which are coming out to be unknown. Question number 3 was very, very easy. In none of the question you had any complicated calculation. They're very straightforward. Question number 4 I left, that I will discuss question number 4 in the next class. Let's start today's discussion with question number 4 of section A. 20 marker question. एकदम बिल्कुल straightforward question है. State how for spin half particles the spin can be expressed by its 3 components sigma x, sigma y, sigma z. 20 marker question. इसी में यूपीएससी को अगर कॉम्प्लिकेट करना होता है तो फिर क्या करेंगे, वो आपको सिग्मा z दे देंगे एंड आपसे पूछेंगे कि सिग्मा x, सिग्मा y का प्रोबेबिलिटी फिर क्या होगा. दे विल आस्क अबाउट अ स्पेसिफिक स्पिन स्टेट which when measured in z axis this is what we got, and when we measure the x or y what will we get. That will be a more complicated question. पूछा भी है यूपीएससी ने पास्ट में, बट ये तो स्टार्टिंग पॉइंट है that how do we derive polyspin matrices, और वो भी 20 मार्क्स का है. So this question deserves that entire derivation. Look at the second question. By applying Schrodinger equation to the ground state of hydrogen atom, determine the 0 point energy. And it's a 15 marker question. अब यहाँ पे the moment you start thinking about that, do we have to solve the entire Schrodinger equation which we have learned in 15 marker. By the way, अगर ये 20 नंबर का भी आता, the complete solution to hydrogen atom, I will never attempt that question. 5-6 पेज का solution है. Why would I do that? But this question is not saying that. This question already has specified that we are talking about ground state. ठीक है? And that will simplify our calculation a lot. I will show you that this is a question which is worth attempting. Last question जो है question number 4C, उसमें maths तो है ही नहीं. I do not have to do any calculation. I have to know about these two phenomena, fluorescence, phosphorescence. And then we have to talk about the mechanism responsible, and we have to talk about applications. 15 marker question. ठीक है? Let's do this question number 4 first. How do we operate? I will not, because the goal here is to tell you that how we can write a model answer effectively. So I've done this. Spin operator for spin half particle, this is what we have to calculate. Once we know that there is a property called spin which can take only 2 possible values, then we have to build our own operator for that. Okay. We know few things from experiment, that for spin half particle S half, we get 2 spin state. We can assign that value of ms plus minus half. Okay. So spin operator is defined as h bar by 2 sigma, where sigma has those 3 components, sigma x, sigma y, sigma z, and we aim to derive that sigma x, sigma y, sigma z. ये क्वेश्चन आंसर करते वक्त हम ऐसे करेंगे. आपका क्लास नोट्स में ऐसे नहीं होगा. आपके क्लास नोट्स में आई विल नॉट इमीडिएटली राइट दिस सिग्मा. आई विल फर्स्ट एक्सपैंड दिस एस एंड देन आई विल लेटर डिराइव दैट पॉलीस्पिन मैट्रिसेस. बट क्वेश्चन में डायरेक्टली पूछ रखा है. आई नो द आंसर ऑलरेडी, दैट वी कैन राइट द स्पिन ऑपरेटर एज इन द टर्म्स ऑफ सिग्मा एक्स, सिग्मा वाई एंड सिग्मा जेड. ठीक है? तो कोई भी स्पिन वेव फंक्शन का जो जनरल स्टेट है, दैट इज कॉल्ड स्पिनॉर. The 2 states are possible, but if I am not making a measurement, then a spin half particle can exist in a superposition of either of those 2 states. And if I have specified that spinor, then I have specified that spin wave function, right? So I use that column matrix, 2 element column matrix, which if I expand is nothing but this. That this A here, by measuring that A, I can calculate the probability in plus half state, and by measuring the B, I can calculate the probability in minus half state. This is spinor A chi 1 by 2 plus B chi minus 1 by 2, where chi 1 by 2 is 1 0, chi minus 1 by 2 is 0 1. This is my basis. Every wave function has to be written into certain basis. मेरा जो basis है यहाँ पे, ये column matrix है 1 0 and 0 1. Okay. So from experiment I already know that it takes 2 values, and let's say whatever axis I have measured along, let's call this axis Z axis, that I am measuring this along Z axis. So I already know that if I measure along Z axis, I get this value ms h bar. I know ms is plus minus half. I have not derived this here because ये question का part नहीं है, but this can be derived. It will just take half of page, that any general spin operator can be written as that 2 by 2 matrix. Again, there is a proper step that how I have directly written it here. I know this, hence I have written it. अगर आपको नहीं पता है, आप हाफ पेज और आपको स्पेंड करना पड़ेगा, बट उसके एक्स्ट्रा मार्क्स नहीं मिलेंगे आपको, बिकॉज क्वेश्चन का डिमांड नहीं है. क्वेश्चन इज आस्किंग यू टू डिराइव सिग्मा एक्स, सिग्मा वाई एंड सिग्मा जेड. सो जनरल स्पिन ऑपरेटर, लेट मी टेल यू जस्ट इन केस दैट हम करेंगे कैसे. यू स्टार्ट विथ सम स्पिनर ए बी and you write that if I use this operator S on that spinor, I get this CD. You start with this and then you expand and you get this particular solution. ठीक है. So matrix of SZ निकालते हैं. SZ का matrix क्या होगा? Any matrix can be written as chi half S chi half, half minus half, माइनस हाफ प्लस हाफ, माइनस हाफ माइनस हाफ. अब ये बस S हमको चेंज करना है. दैट S कैन बी S स्क्वायर वेयर आई एम टोटलिंग मेजरिंग द टोटल स्पिन एंगुलर मोमेंटम, और SZ which I already know. So I will now use that bracket notation, that if this S is SZ and if I operate SZ on plus half, I already know that it is in plus half state. I know that eigenvalue, that is h bar by 2. So I get chi half, this is normalized, so this is nothing but 1, this I simply get h bar by 2. But if I operate this on minus half, the eigenvalue is h bar by 2, but now I am taking that inner product of half and minus half. These are orthogonal state, and orthogonal state will be 0. Similarly, that third element, minus half plus half, that will also be 0. Last element, that will be minus h bar by 2. So I get SZ is h bar by 2, 1 0 0 minus 1, which immediately allowed me to calculate sigma z is 1 0 0 minus 1. Okay? So this calculation we have done with help of experiment. With experiment I know two possible values of spin, and then I am fitting that experimental data into my mathematical framework. And based on that mathematical framework, I got that sigma z. But now I want to generalize this mathematical framework for other things also. अब यहाँ पे Sx and Sy के बारे में हमारे पास information नहीं है, because we already know that in angular momentum, L square and one of the component, they commute. So I can measure L square and Lz together, but I cannot measure Lx and Lz together. So I measured Sz, and I can measure SS square, right? But I do not know Sx and Sy. So directly मुझे नहीं पता है. But here I will use that now the knowledge of that raising up and lowering down operator. That I will use Sx and Sy can be written as S plus plus S minus divided by 2, and Sy can be written as S plus minus S minus divided by 2i, because I already know that S plus is Sx plus Isy and S minus is Sx minus Isy. उसी को मैंने डायरेक्टली यहाँ पे ये लिखा है. एंड S प्लस एंड S माइनस हम इजीली ऑपरेट करा सकते हैं. जो हमने अभी ऊपर फॉर्मूला लिखा है, यहाँ पे आप ये S प्लस कर दो. इफ दिस इज S प्लस and it is operating on half, it already is higher state. But if this is operating on minus half and it is S plus, then it convert minus half to plus half, and then it becomes H bar. This, it again already is plus half. I am using S plus, this becomes 0. So I get just one element. So I have directly written that answer. I do not have to write down all of the terms. That will simply take more time. I have directly written this. ये मैंने पूरा मैट्रिक्स नहीं लिखा है कि ये काई हाफ एस प्लस काई हाफ। आप एग्जाम में भी आप यही करोगे, आप एग्जाम में लिखने बैठोगे उसमें आप सोचोगे आपका 1 मिनट एक्स्ट्रा लग गया, सिंपली राइटिंग दैट काई हाफ एस प्लस काई माइनस हाफ एंड ऑल ऑफ दैट. So you save time. So you get S plus and you get S minus. And then I know Sx and Sy. Sx was S plus plus S minus divided by 2. So यहाँ से Sx आया. So यहाँ से I get that Pauli matrix 0 1 1 0. And Sy is h bar by 2 0 minus I 0. I get 0 minus I 0. So I have now written all of the three Pauli spin matrices. I have done first part of the answer. The second part of the answer is इसके properties क्या हैं, right? All of them are Hermitian matrices. This can be proven and that makes a lot of sense because only if it is a Hermitian operator, only then it will lead to measurable outcome, measurable value. सबका trace 0 है, देख सकते हो, सबका जो diagonal है अगर आप उसको add करोगे, it is 0. All of them are unitary matrix. Take square of them, all of them become I. सबका determinant जो है -1 है. And जो commutation relationship ऐसा है that sigma x sigma I y, that is 2i sigma z and so on. Sigma y sigma z, 2i sigma x, sigma z sigma x, 2i sigma y. इसी को हम ऐसे लिख सकते हैं. All three of that can be written as this into that specific notation. And eigen values जो हैं सबके eigen values plus minus 1 है. आप सबके eigen value निकालो, eigen values will be plus minus 1. All three Pauli matrices. And one last thing which if you write, by the way, I'm very sure you'll get that extra marks, that they provide completeness. That any 2 by 2 Hermitian traceless matrix can be written as A dot sigma. That they can form a basis for certain type of matrix. So these are all of the even if you write 3 or 4 of these properties, even then you will get marks. I have written 6 properties here, but I do think that you should write at least 4 properties of Pauli spin matrix. This is one of the most popular topic for UPSC. Every year 10 marker, 15 marker or 20 marker question will be asked. And the best part is, this is the simplest part in quantum mechanics mathematically. Because यहाँ पे जो mathematics है बहुत simple है. Matrix आपको multiply करना भी है तो 2 by 2 matrix multiply करना है. Right? So this is a topic which should be done really, really well because it can fetch lot of marks while you'll spend very less time in actually answering that question. The next question, as I told you, the question is saying that you have to calculate energy in the ground state. That is already given. Okay. अब यहाँ पे अगर आप पूरा Schrödinger equation solve करने बैठोगे तो कुछ भी फायदा नहीं होगा. ठीक है. The fact that I already know answer to ground state is going to help you a lot. And इसीलिए हम practice करते हैं. Why we practice same problem again and again? Because I already know what is ground state. And that knowledge will help you a lot in this specific question. ठीक है. I start with this assumption that nucleus is infinitely heavy, so I'm assuming that nucleus is stationary. अगर नहीं भी stationary हम assume करते हैं तो बस हमको यहाँ पे m के बजाय जहाँ पे mass मैं ले रहा हूँ mass of electron, वहाँ पे बस मुझे reduced mass लेना पड़ेगा. Remember 2 body problem? I can convert 2 body problem to 1 body problem by using reduced mass mu, m1 m2 by m1 plus m2. But मैंने starting में लिख दिया that I'm assuming that nucleus is infinitely heavy. In that case, that reduced mass is same as that lighter object. In this case, that lighter object is mu. My Schrödinger equation is h2 by 2m del 2 psi plus v psi, but v is that Coulomb potential minus e square by 4 pi epsilon naught r psi e psi. Now psi generally will have 3 components. It will be r, theta and phi. But here the question is already telling you that you are into ground state. If you are into ground state, then we are saying that n is equal to 1. And जो L and M है ये दोनों 0 हैं. From angular momentum problem, अगर आपको ये नहीं याद है कोई बात नहीं, but मैंने लिख दिया है कि यहाँ पे ये जो angular component है that is constant 1 by square root of 4 pi. Even इसका कोई extra marks नहीं मिलेगा. You will not get any extra marks for this. but you have to write this. That in ground states, n is equal to, in ground state, n is equal to 1, L is equal to 0, M is equal to 0. Okay. Which means that the moment I reduce that radial part, sorry, reduce that r theta phi only into radial part, यहाँ पे एक अगर आपको याद हो, you'll get a term L plus 1 by r square जो centrifugal term है. यहाँ पे L 0 है, I do not have to worry about that part. So your radial equation reduces directly to this. One more thing, अगर इस क्वेश्चन को मैं यहां से भी स्टार्ट करता, मैं हाइड्रोजन एटम डायग्राम बनाता एंड मैं डायरेक्टली लिखता दैट द रेडियल पार्ट ऑफ हाइड्रोजन एटम, आपको याद रखना पड़ेगा फिर कि वो रेडियल पार्ट क्या है. द रेडियल पार्ट ऑफ हाइड्रोजन एटम, अब डायरेक्टली वहां से शुरू करो, इवन देन दैट इज परफेक्टली फाइन. ठीक है. व्हाट शुड आई डू देन? अब एक तरीका ये है कि आप क्या करो, जिस तरीके से मान लो कि जब हमने सॉल्व किया था हाइड्रोजन एटम, वी सॉल्व दैट फॉर जनरल L वेयर L वाज नॉट 0. हियर L इज 0, बट इवन देन यू स्टार्ट डूइंग दैट सेम सोल्यूशन. जैसे अगर आपको याद हो, सोल्यूशन ऐसे शुरू होगा दैट यू आर गोइंग टू एज्यूम R इज इक्वल टू सम UR बाई R. ठीक है. एंड वहां पे फिर आप dr बाई dr लोगे, एंड ये वाला जो टर्म है दैट इसेंशियली विल बिकम du बाई dr. इट विल सिंप्लीफाई अ लिटिल बिट. कुछ करने की जरूरत नहीं है. नन ऑफ दैट इज रिक्वायर्ड इन दिस पर्टिकुलर क्वेश्चन, बिकॉज आई ऑलरेडी नो दैट एंगुलर कंपोनेंट जो है दैट इज कांस्टेंट, दैट इज नॉट गोइंग टू कंट्रीब्यूट टू एनीथिंग. सो आई डू अ ट्रायल सोल्यूशन, आई एज्यूम a trial solution, and that is why I told you that because I have done this problem, I know that solution takes this form. Two constants, think about it, double order linear differential equation, the solution hoga I will get two constant, A and A naught. I do not know A, I do not know A naught. This I aim to calculate. That A naught is called Bohr radius, and let's hope that by doing this, by using this particular solution, I will be able to get energy. That is why he said that this knowledge of the ground state solution is going to help you. So I assume that R is equal to A e raised to the power minus R by A naught. Okay? And then I differentiate and I fit this here. Would you like to solve this? आपके पास notebook pen है, I will give you 2-3 minutes. That solution, I'm giving you this solution. I'm saying that let's assume that R of R, ये जो function है, let's assume that it is some constant A, E minus R by A naught. And I'm saying that this is a solution. If this is a solution, then let's put this value here and let's see that do you get something. I will give you a hint. To reduce the complexity, do not use minus h by 2m immediately. अब सिर्फ इसको अभी कैलकुलेट करो. Just tell me that ये वाला टर्म क्या आएगा. Those who are watching it live, you can also do that at home. That इस पार्ट को कैलकुलेट करके देखो क्या आएगा. And then put that with minus h to h square by h bar square by 2m. And then I will use a very neat argument. What did you get? Okay. What are we going to do after that? So this is going to be if you solve this, this is what you are going to get. I'm only taking that part. 1 by r square d by dr of r square dr by dr. I've simply first solved this. And when I solve this, I get this. Yeah. A 1 by a naught square minus 2 by a naught r into e raised to the power minus r by a naught. Only the first part. I multiply minus h bar square by 2m and then I also take minus e square by 4 pi epsilon naught r here. ठीक है, ये मेरा solution है. जो मेरा equation था, equation 1, this reduces to this equation. What do I do this? What do I do after this? How do I get that energy? Follow the argument. What was the argument? That I assume that this is the solution, and if this is the solution, then it should fit into, it should solve my differential equation. So when I put this r into my differential equation, I get this expression. Minus h bar square by 2m, 1 by a naught square minus 2 by a naught r minus e square by 4 pi epsilon naught r, capital R, is equal to ER. How do I calculate energy from there? There is a simple, neat argument I am going to make. The potential is radially symmetric. The solution was also radially symmetric. Okay? So for all values of r, I can make a circle, I can make a sphere. For all values of that small r, that energy is constant. Can we see this? That for all values of that E, यहाँ पे R common है, I can remove that capital R here. आप देख लो, सबसे पहले तो I can remove this capital R. This is common. I do not have to worry about capital R. Now I am saying that for all values of R, E is constant. But R in itself is not constant. R is a vector, and that vector can change. But irrespective of that R vector, that energy has to be the same. Which means that any component here on right hand side which has 1 by R into it, that coefficient should be 0. And then the remaining part will essentially be nothing but the energy. That is the argument I make. That is what I have written here. E is same for all R, and that is only possible because यहाँ पे देखो ये R तो ऐसे ही खत्म हो गया. I have two components with 1 by R, 1 by R and 1 by R. तो ये 1 by R का जो coefficient है that should be 0. And उसके बाद ये वाला जो constant बच जाएगा, that constant will be my energy. ठीक है? So I do this. E is same for all R. That is only possible when 1 by R coefficient vanishes. So if this condition is fulfilled, then the solution I had assumed is the correct solution. Okay? And the moment I fulfill that condition, I get that A naught. That h bar square by ma naught minus e square by 4 pi epsilon naught into 1 by r, that is 0. यहाँ से I get A naught, that bow radius 4 pi epsilon naught h bar square me square 0.529 angstrom. And if I know this, if this is 0, then the constant, the only constant which is left here is minus h bar square by 2m a naught square, that is E. यहाँ पे एक R था, यहाँ पे R था, that R vanishes. This is, and I have just calculated A naught. I put that A naught and I have my answer. Minus ME4 32, so 4 square 16 into 2 32 pi square epsilon naught square h bar square. Put all of that, it comes out to be minus 13.6 electron volt. I do not, ये चीज़ आप वहाँ पे calculate नहीं करोगे. बोर एनर्जी का ग्राउंड स्टेट ऐसे टंग पे होना चाहिए, लाइक -13.6 EV, ठीक है. Negative sign signifies bound state, which was of course very obvious. So the point I'm trying to make here is that ये question में problem तब होगा when you start solving Schrodinger equation in the same way you learned in your basic derivation. And here the knowledge of this final solution is going to help you in reducing the mathematical complexity. ऐसा नहीं है कि जो हमने मेथड क्लास में किया था उसे सॉल्व नहीं होगा, उसे हो जाएगा, बट इट इज गोइंग टू बी मोर कॉम्प्लिकेटेड मेथड. द लास्ट क्वेश्चन, फ्लोरोसिन एंड फॉस्फोरोसिन. जो फॉस्फोरोसिन है, फॉस्फोरोसेंस जो है, आई एम फ्रॉम बिहार एंड एक बड़ा फेमस एक सॉर्ट ऑफ सुपरस्टिशन है हमारे यहाँ, मेरे विलेज में, दैट व्हेन वी वर चाइल्ड वी सॉ दैट शाम के टाइम पे some light is coming from some object, and then people used to say that वो कोई local goddess है, and locally it was called Luk Devi. You Luk Devi है. And now I know that it was nothing but phosphorescent. There was some phosphorescent material which was essentially producing that light for minutes and sometimes in fact for hours. So both fluorescein and phosphorescent, they both are first example of what is called photoluminescence, which simply means that they absorb some light, some frequency, and then they emit light, visible light, hence the word photoluminescence. The problem is, or the difference is, that this transition from high energy to low energy, in case of fluorescent, this happens following a selection rule, which is completely allowed. तो ऐसे क्वेश्चन का देखो बेस्ट तरीका यही होता है कि आप टेबल बना के कंपेयर कर दो, रादर देन पूरा पैराग्राफ में सब कुछ लिखो. यू मेक अ टेबल एंड यू कंपेयर दैट. क्वेश्चन में दे भी रखा है, डिफरेंशिएट बिटवीन फॉस्फोरोसिन एंड फ्लोरोसिन. सो फ्लोरोसिन, सिंगलेट टू सिंगलेट ट्रांजिशन, यू गो टू हाई एनर्जी स्टेट, यू कम टू लो एनर्जी स्टेट. इन बोथ ऑफ दैट जो आपका स्टेट है वो सिंगलेट टू सिंगलेट है. इन फॉस्फोरोसिन यू डू दैट ट्रिपलेट टू सिंगलेट, विच इज़ नॉट अलाउड. लाइक नॉट अलाउड इन द सेंस दैट it is forbidden, which means इसका probability बहुत कम है. अगर probability बहुत कम है, then this transition is going to take lot of time. So selection rule delta S is equal to 0. In fluorescein this is allowed. In phosphorescein, that's delta S is equal to 0 is violated. So this is a forbidden transition. And forbidden in quantum mechanics means very low probability, which translates to very large transition time. And that is why you immediately find that lifetime here will be nano to microsecond. Here it can be millisecond, but it can also go to minutes and sometimes hours. It can also go into double digit of minutes. So after excitation, fluorescein immediately vanishes, nanosecond transition. Phosphorescein, it continues for very long. And this is the diagram. This diagram is called Jablonski diagram, the scientist who explained it. That you are into some low energy state, absorbed a photon, went to high energy state, but in both the cases this is a singlet state. And in case of phosphorescein, there is a triplet state also available. So you went to singlet, but the transition is now happening from triplet to that ground state, and this is forbidden, and which essentially means that it takes, the transition happens for minutes and hours. एक और difference ये भी है, जो फ्लोरोसिन है वो टेम्परेचर से बहुत ज़्यादा सेंसिटिव नहीं है, और जो फॉस्फोरोसिन है दिस इंक्रीजेज विथ कूलिंग. एंड उसका कारण ये है दैट यू फाइंड ट्रिपलेट स्टेट्स बिकमिंग मोर स्टेबल एट लो टेम्परेचर, एंड एज अ रिजल्ट ऑफ दैट मोर ट्रिपलेट स्टेट्स मीन्स दैट मोर टाइप ऑफ फॉस्फोरोसेंट ट्रांजिशन. एंड दे बोथ हैव रिमार्केबल एप्लीकेशंस. दैट इज द लास्ट पार्ट ऑफ द क्वेश्चन, दैट वेयर डू वी यूज देम. वी यूज दिस इन माइक्रोस्कोप, इन सेलुलर इमेजिंग. We use this in cancer diagnosis. We use this in DNA sequencing. जो DNA का जो base pair है, that base pair has a very specific fluorescent mark, and we use that. And of course we use this, the simplest application is LEDs and fluorescent lamp. Phosphorescein, इसका जो सबसे famous day to day application है वो OLED display है. That some rare earth elements, they exhibit this phosphorescent property, and that has application in OLED displays. But that glow in the dark material, or again biological imaging, or anti-counterfeiting. In some notes, currency notes, that phosphorescent dye is used for anti-counterfeiting. So these are the applications which you have to mention. वेरी सिंपल क्वेश्चन, कहीं पे कोई मैथमेटिक्स करने की ज़रूरत नहीं है. Do you have any question in question number 4? The first was polyspin matrices, the second is hydrogen atom, the third is from that molecular, atomic and molecular physics. I mention this always in the classes, that atomic and molecular physics सबसे easy part है पूरे के पूरे syllabus का, and this should be done really, really well. Okay, let's go to the section B. In section B, I have done question number 5, 6 and 7. So I have solution to 7 questions, you can choose any 5. Look at that first question. Show that energy of the triplet state is not equal to energy of the singlet state. इस क्वेश्चन का जो इंस्पिरेशन है वो कहाँ से है पहले तो लेट्स स्टार्ट विद दैट. एक्चुअली मेन मोर देन वन इंस्पिरेशन, बट ये क्वेश्चन देयर इज अ हिंट हियर, दिस इज अ क्वेश्चन इन न्यूक्लियर फिजिक्स. तो न्यूक्लियर फिजिक्स में क्वेश्चन क्यों दे रखा है ये? बिकॉज बाय द वे यू ऑल्सो स्टडी द सेम थिंग इन एटॉमिक एंड मॉलिकुलर फिजिक्स. तो न्यूक्लियर फिजिक्स में देने का क्या मतलब है यहाँ पे? Do you remember your nuclear physics class notes? You have to do that. It still amazes me that how theoretical physicists help in experimental physics, but vice versa is also, that is also very dominant and very prominent. This is an example of that vice versa. That when in nuclear physics people clearly knew that the nuclear force it is not same as electromagnetic force, it is something different, and they wanted to know what it is. They wanted to know its property. Initially they assumed that it is a central force. Later they realized that no, it is not completely central force. Of course they knew that it is not dependent upon charge, because it is also happening between proton and neutron, or neutron and neutron, so it is a charge independent force. But one thing which allowed them to come to a conclusion, that it is a spin dependent force. जो nuclear force है, it depends upon spin states, and this was a result of an experimental data. With help of experiments, so think of the problem which, by the way, I was looking for, the answer which I was looking for was deuteron problem. This question is asked here because of deuteron problem. Deuteron has one proton plus one neutron. ठीक है? Proton is a fermion, neutron is also a fermion. I have two spin states possible, 0 and 1. 1 by 2 minus 1 by 2, 0. 1 by 2 plus 1 by 2, 1. Singlet, triplet. ठीक है? When I calculate the nuclear spin, I find this, that I is equal to 1. ठीक है? So now I have to calculate L, and when I see L, I is equal to 1 by the way. When I see L, then L takes only two possible values, 0 and 2. That either it is s orbital or it is d orbital. Now the point is that we do not find s is equal to 0, which is possible. If you use all of the permutation and combination, you will find that deuteron, जो भी अभी तक हमने एटॉमिक एंड मॉलिकुलर फिजिक्स में किया था, उसके बेसिस से ड्यूटेरॉन शुड और कुड एग्जिस्ट इन s इज इक्वल टू 0, बट वी नेवर फाइंड दैट. वी ऑलवेज फाइंड दैट ड्यूटेरॉन, इवन दो s is equal to 0 is not forbidden as per selection rule, deuteron exists into s is equal to 1, then L is equal to 0 2, and only then I becomes, this is the experimental data, that I is equal to total nuclear spin जो है मेरा वो 1 है. So this gave this idea to scientists, and that is why what amazes me, that how experiments help you in developing hypothesis. That जो strong force है, it is a spin dependent force. But ये आंसर खाली अगर आप इतना करोगे तो नहीं है, आपको मैथमेटिकली यहाँ पे दिखाना पड़ेगा कि ये दोनों डिफरेंट कैसे हैं. But this is where I will start with. I will immediately set up the problem that why this question has been asked here. इसी क्वेश्चन को एक और तरीका आंसर करने का. I have chosen deuteron problem because this question was asked in nuclear physics. I could have answered this same question अगर atomic and molecular physics में हो, then I'm going to use the fact that how S is equal to 0 or S is equal to 1 are two very different type of linear superposition. One is symmetric, another is anti-symmetric. But anyways, maybe in some other discussion. I mentioned that to show this difference, we are using Deuteron problem. Deuteron jo hai, this exists in a triplet state. I mentioned this also. I is equal to 1, this is experimental data. S is equal to 1, L is equal to 0 or 2, though S is equal to 0 is possible. अगर S 0 हो और L जो है मान लो मेरा 1 हो या L 0, I can have this, L मान लो 1 हो, then I can get that I is equal to 1. But I never find that. I find that S is always equal to 1. S is 0 possible. And that led to that conclusion that somehow जो spin dependence है, that is adding the attraction. The triplet state is adding the attraction, singlet state is maybe causing some sort of repulsion. As a result of that, in nuclear force, you get a bound state in triplet state, you do not get a bound state into singlet state. तो इसको प्रूफ करने का जो तरीका है वो बहुत सिंपल है. हम क्या करेंगे? I know now that strong 4 potential जो है, it has a central potential component, it does depend upon R, but there is also that spin dependence. So I assume that the total potential has that central potential component, and then that spin component is also there, where that V spin here represents right now some sort of positive value. I have to calculate sigma 1 dot sigma 2, that sigma 1 sigma 2 that represents spin of proton and neutron. So sigma 1 sigma 2 I will use Pauli spin matrix का जो हमारा knowledge है, we are going to use that. I already, हमने अभी just problem भी किया, S is equal to h bar by 2, sigma I know that, S1 dot S2, that is nothing but h bar square by 4, sigma 1 dot sigma 2. Okay. I want to calculate that. What is that sigma 1 dot sigma 2? So I know that total spin, it's spin of proton, spin of electron. I take square, SS square, this becomes S1 square, S2 square, plus 2S1, S2. So I know S1 dot S2 is 1 by 2 SS square minus S1 square minus S2 square. ठीक है? But S1 square and S2 square, that is nothing but 3 by 4 h bar square, SS square, 3 by 4 h bar square. And SS square, if I measure that, that will come out to be SS plus 1 h bar square minus 3 by 4 h bar square minus 3 by 4 h bar square. So I have h bar square by 4, sigma 1 dot sigma 2, I already had done this. H bar square common hai, h bar square by 2, SS plus 1 minus 3 by 2. This is the relationship I get. Sigma 1 dot sigma 2 is equal to 2 SS plus 1 minus 3 by 2. But there are now two possible values of S. If both proton neutron spin aligns, then I get that triplet state. S is equal to 1, sigma 1 dot sigma 2, SS plus 1, so 1, 1 plus 1, minus 3 by 2, I get plus 1. And if it is a singlet state, one is up, another is down, then I get S is equal to 0, sigma 1 dot sigma 2, 2 into 0, 0 plus 1, 0 into A 0 hai, minus 3 by 2, so 2 into minus 3 by 2 I get minus 3, okay. Which means that for S is equal to 0, ये जो भी V spin है, I multiply that with minus 3, and for S is equal to 1, I multiply that with plus 1. That minus 3 enhances attraction, that negative potential. That plus 1, that enhances repulsion. So that minus 3, this positive potential, S is equal to 1, that plus 1 here, total potential is adding up, sorry, I misspoke. Total potential is adding up, potential becomes more negative, enhances attraction. And here, that potential becomes essentially, that causes repulsion. And that justifies that singlet and triplet states do not have the same energy, and that also justifies that why deuteron only exists in triplet state and not singlet state. तो अगर हम खाली आर्गुमेंट लिख के आगे बढ़ गए होते देन उतने मार्क्स नहीं मिलेंगे हमको. जैसे अगर हमने खाली आर्गुमेंट लिख दिया that singlet and triplet state are not same because even though for deuteron both of them are available, deuteron only exists into triplet state. I will not be surprised that if same question is repeated now in future. And I will also not be surprised that if same question is asked in 15 marks rather than 10 marks in this particular case. Okay. So this was a good question. Another very, very good question which I absolutely loved in this paper is this one. That you have two mesons, both decay mostly to pions, pi plus and pi minus. Why the mean lifetime of one of is 10 to the power minus 23 and for another it is 10 to the power of the order of 10 to the power minus 10. What do you think? How are you going to solve this? हमारा instinct क्या होगा? That we will use energy uncertainty principle, Heisenberg energy time uncertainty principle. But of course उसको आपको use करना पड़ेगा. The problem is that अगर आप खाली उसको use करोगे then you will not find the correct answer because energy level क्या है interaction होने के लिए वो आपको भी पता नहीं है. वो जो डेल्टा ई है you have to calculate that delta into tau is h bar. यही करते हैं ना ऐसे क्वेश्चन में, that we calculate delta E into tau, that is h bar. That tau essentially tells you the mean lifetime. ठीक है, so tau here is that h bar by delta E. h bar तो same है, so clearly delta E is different. तभी ये tau अलग अलग है. एक के केस में delta E बहुत ज़्यादा है तो टाइम कम है, एक के केस में delta E कम है तो टाइम यहाँ पे ज़्यादा है. so अब Why I am doing it like this कि अब हम इस पे आएंगे कि डेल्टा ई दोनों के केस में अलग अलग क्यों है. I will give you a moment to think about this. Have you done particle physics? आपने करा हुआ है बट आपने रिवीजन नहीं करा है. For that we will have to figure out कि जो interaction है. So I have two interactions. That rho is going to pi plus plus pi minus. And that k is going to again pi plus plus pi minus. To actually answer this question, I have to know the quark structure here. You have to know the quark structure of rho and k. And you will immediately find, do you remember the quark structure? Please go and revise this. This is particle physics is another very, very easy topic which one should do really, really well. Because कहीं पे कोई कॉम्प्लिकेटेड मैथ्स नहीं है, सिंपल सा लॉजिक है, हमको अप्लाई करना है, कॉन्जर्वेशन लॉज हैं, अप्लाई करना है, हमारा आंसर हो गया. रो मेजॉन है, दिस डज नॉट हैव एनी स्ट्रेंज क्वार्क, इट इज़ ओनली मेड ऑफ अप क्वार्क एंड डाउन क्वार्क. जो के मेजॉन है दैट इज मेड ऑफ स्ट्रेंज क्वार्क, देयर इज वन स्ट्रेंज क्वार्क देयर. तो यहाँ पे जो स्ट्रेंजनेस है वो जीरो है. आई स्टार्ट विथ zero strangeness, my output product also is zero strangeness. Strangeness is conserved, the decay happens via strong interaction. तो fundamentally जो answer है, and strong interaction का जो energy level है, that comes out to be about 10 to the power minus 11. If I calculate that into joule, in case of EV it will be very high, and as a result of that जो tau है that will come out to be 10 to the power minus 23 second. But if I do that for K meson, that has a strange quark, and strange quark का जो strangeness है that is -1, so it has anti-strange quark. It has one down quark. Remember mesons are made of one quark, one anti-quark. So we have one down quark, one anti-strange quark. So इसका जो strangeness है that S is equal to +1. So I start with S is equal to +1, but जो मेरा pi plus pi minus है, pi does not have any strange quark. So here my initial state is S is equal to 1, my final state is S is equal to 0. So strangeness is being violated, and strangeness is violated in which interaction? Weak interaction. So the second reaction is happening via weak interaction. That is the answer. That the first reaction, दोनों में same by product है, final product same है, but जो process है अलग है. The first one is happening via strong, the second one is happening via weak. And weak interaction का जो energy है वो कम है, and as a result of that उसका जो life time होगा वो ज़्यादा होगा. ठीक है. So that is the final answer which you have to provide. तो यहाँ पे अगर आपने वो नहीं बता पाए, अगर आप that fundamentally the first one is happening via strong, the second one is happening via weak, you will not get marks. That is why this was one of the most beautiful questions in this paper. That you simply have to figure out that what is the fundamental interaction behind this particular reaction. आपको मैंने मेल किया था. ये क्वेश्चन तो मुझे याद है, क्लास में खाली आप ही ने सॉल्व किया था. Find the radius of interstitial sphere which can just fit into the void at the body center of FCC structure coordinated by the facial atoms. So we remember FCC structure. Question देखो क्या है? Question ये है FCC, one atom at the corner shared with 8 other lattices and one at every face shared with 2 lattices, 2 different lattice points. So the question is asking that it is completely filled, but at the body center there is a void, and then in that void I put a small sphere which just fits into that void. उस sphere का radius आपको निकालना है. That is the question. ठीक है. Even if I do not know the coordinate geometry, although I know the coordinate geometry in case of FCC, so I have written it here. That body center का पहले तो coordinate देखो क्या होगा. If I choose this as my origin, body center का this as origin, this can be my origin. So body center coordinate will be a by 2, a by 2 and a by 2. And जो 6 nearest atoms हैं, their coordinate will be a by 2, a by 2, 0, a by 2, a by 2, a. अगर ये नहीं भी लिखता तो काम चल जाता. I mentioned it here. So distance from the body center to the nearest face center, that I have calculated, that distance is a by 2. अगर ये नहीं करते, अब डायग्राम अगर आप 3 डायमेंशनल डायग्राम इमेजिन कर लो तो उससे भी क्लियर हो जाएगा. That I have one atom which is one part of that. Think of this as a sphere which goes till the body center, and then another which goes till the body center, and इन दोनों के बीच का जो distance होगा that will be nothing but a by 2. ठीक है. And if I want to calculate this in, let's say, radius of the atom, then I also know that in case of FCC, R and A का हमारा क्या relationship है. ठीक है. So now the question is that जो void है, in that void I put a small sphere. So if that sphere has a radius small r and that atom has the radius capital R, that r plus r should be that d. This is a by 2, and that r becomes simply a by 2 minus r, which is a by 2 minus a root 2 by 4. एंड इसी ए को अगर आप कैपिटल आर के टर्म में लिख दो, अभी हमने कैलकुलेट किया, दिस विल कम आउट टू बी रूट 2 माइनस 1 कैपिटल आर. सो दिस इज अ सिंपल, वेरी सिंपल केस ऑफ 3 डायमेंशनल ज्योमेट्री. डू यू अंडरस्टैंड 3 डायमेंशनल ज्योमेट्री? द आंसर विल बी 0.4 टाइम्स कैपिटल आर. दैट विल बी द रेडियस ऑफ दैट स्मॉल स्फेयर यू हैव पुट देयर. Such questions should make you very happy because ये 5 लाइन का आंसर है. Although यहाँ पे एक ट्रिक है थोड़ा सा, like they have not given this, have they given this somewhere here? Constants में तो नहीं दे रखा, constant तो कुछ दिया ही नहीं है. Okay, anyways. In powder diffraction method pattern for lead with a radiation of wavelength lambda and आपका जो मिलर इंडिसेस ऑफ प्लेन है वो भी दे रखा है 2 to 0, थीटा दे रखा है. फाइंड द रेडियस ऑफ एटम. सो डी तो आप इमीडिएटली निकाल लोगे, इंटरप्लेनर डिस्टेंस आप इमीडिएटली निकाल लोगे, बट डी नहीं पूछा है. पूछा यहाँ पे रेडियस ऑफ एटम है, लेड दे रखा है. तो डी से हम एटॉमिक रेडियस कैसे कैलकुलेट करेंगे? वी हैव टू नो विच टाइप ऑफ क्यूबिक स्ट्रक्चर इट इज, एंड देयर आर 3 क्यूबिक स्ट्रक्चर्स विच आर पॉसिबल. सिंपल क्यूब, बॉडी सेंटर्ड क्यूब एंड FCC, फेस सेंटर्ड क्यूब. अगर कभी भी इस टाइप का क्वेश्चन आए और मन में डाउट हो तो एज्यूम FCC. एज अ थंब रूल याद रखना, बिकॉज मैक्सिमम जो लैटिसेज हैं वो FCC है, एंड लेड इज बाय द वे FCC. आप ऐसे भी सोच लो कि सिंपल क्यूब तो बहुत ही रेयर है, उसका पैकिंग फ्रैक्शन इतना ज़्यादा है दैट सिंपल क्यूब हार्डली एक और दो एलिमेंट हैं विच हैव दैट सिंपल क्यूब स्ट्रक्चर. मेजॉरिटी ऑफ द एलिमेंट्स हु गिव क्यूबिकल स्ट्रक्चर they have a proper FCC, and then you have BCC, and one or two of them has that simple cube if it is a cubical lattice. Among all of the cubical lattice, FCC has like some 60-65% of the elements have that FCC structure. So ये बहुत ही simple question है. I already know Bragg's law. 2d sin theta is equal to n lambda. n यहाँ पे दे रखा है 1 है, हमने d निकाल लिया. d comes out to be 1.453 angstrom. For a cubical lattice, I also know that d is nothing but a by h square plus k square plus l square. वहाँ से हमारा a निकल गया, but I do not have to calculate a, I have to calculate the radius of the atom. And there, this knowledge is going to help me that lead has a FCC. And I repeat this, अगर question में कुछ भी नहीं दे रखा है तो आप FCC assume कर लेना. Right? So I calculate that R will come out to be some a root 2 by 4. अभी हमने देखा ऊपर ही R and A का relationship, a root 2 by 4. That is 1.45 angstrom, right? I again get fascinated by this fact that just by measuring basic things we can know about the atomic radius of lead. How cool is that? That we can actually measure the atomic radius of lead by simple experiments. Okay, this is a question of electronics, particularly transistors in communication system, JFET and MOSFET. And this is something, if you have done it, only then attempt it. If you have not done it, simply skip it. In solid state physics devices electronics, जो पूरा ये electronics component है, this part. So solid state physics का अगर आप syllabus देखोगे, तो you'll find that पहले तो ये है कि crystal structure है, then magnetic property है, then thermal property है, then superconductivity है, then some transistors वाला semiconductors वाला पूरा part है, and then it talks about digital electronics. So this part जो है, that is like 2 semester electrical engineering syllabus, right? So if you know this, attempt it. If you do not know this, hardly you will miss upon 10 marks. वो भी कभी कभी होगा, जैसे इस case में you will miss upon that 10 marks because it is a compulsory question. It is at E. What are the differences in electrical characteristic of FET and MOSFET? FET and MOSFET. How does N-channel FET differs from P-channel FET, right? So you have to know this, only then you should answer it, otherwise go to the next question. I have given this. What are the fundamental differences? I have given many differences. Even if you can pick 4 or 5 of them or 4 of them, that is good enough. It's hardly a 7-marker question. And N-channel FET, P-channel FET, again if you write just 2 differences, that is also good enough. Let's look at the next question. Both of these questions, shell model बहुत important topic है nuclear technology का. That how do we understand about certain nuclei which are very stable, and we can only do that with help of shell model. So both questions are from shell model. This is a standard question of 20 marks. State the basic assumptions of single particle shell model. वो भी 10 number का दे रखा है, which is very surprising because the second part है that will take lot of effort. Second part is saying that how do the centrifugal and spin orbit terms remove the degeneracy of 3-dimensional spherical harmonic oscillator. Okay, so the fact that both are of 10 marks, I find that this is like not good. Ideally it should be 5 plus 15 marks. And UPSC in past has asked just the second part as a 20-marker question. How does centrifugal term and spin orbit term, it removes that degeneracy of spherical harmonic oscillator. I will come to that question. But first let's see this question. In fact, let's do this because ये ज़्यादा fundamental question है. Let's do this question number B. Shell model का क्यों, why we thought that we needed shell model? Sorry? We found that there are certain nuclei which are very stable. जैसे when we study electronic configuration, there we find out that there are certain elements which are inert. They are chemically not reactive. They are very stable on their own, inert gases. And we realize that some electronic configurations are very, very stable. where shell is closing. A particular shell is closing. And when the next electron has to go into the next shell, right, and as a result of that, that valence electron, it adds to that chemical reactivity. That gave this essentially that idea that maybe something similar is happening in case of neutrons and protons. That neutrons and protons also divide into different shell, and when a particular shell closes, that leads to that extra enhanced stability, and that we can call that magic number. So we do find that in nuclear physics, there are certain nuclei which have that magic number. Let me show you that. ये मैजिक नंबर है 2, 8, 20, 28, 50, 82, 126. That 126 is the largest magic number you get. Okay. So helium, for example, is very stable, and I'm not talking about helium as a element, helium as a atom. I'm saying helium as a nucleus. That is very stable. Because immediately then see, oxygen is also very stable. Again, I'm talking about oxygen nucleus, because oxygen has 8 protons and also 8 neutrons. Both of them are doubly magic number. 8 is a magic number, proton neutron का अलग अलग magic number होगा. Now the problem was that when you do this for atomic physics, when you do this for electrons, then electrons are governed by electromagnetic interaction. Electromagnetic interaction we understand really, really well. In fact, that is the only interaction we understand with everything what is there to understand. Among 3 other we do not understand. Gravity was the first to be discovered. We still do not understand gravity. Strong we understand more or less. Weak we understand more or less. But there are many aspects of it which we do not understand very well. So people solved Schrodinger equation using that Coulomb potential, and they found all of those magic numbers very easily. But strong force ka potential kya hai, strong force ka nature kya hai, that was not very clear. So people made certain estimates. Okay, let's assume this is the potential. Let's assume this is the potential. And then let's try to see that do we get this magic number or not. Okay? So one of the potential, for example, people assume there is a square well potential, a 3-dimensional square well potential. Then another potential which was assumed is that assume this as a 3-dimensional spherical harmonic oscillator. The most closest potential is Wood's action potential, right? So that is the most closest. I will discuss that in our nuclear physics. But shell model mein we start with that spherical harmonic oscillator potential. So shell model ke assumptions pehle kya hai? Let's start with that. It is called single particle shell model. वो नाम बहुत important है. जो single particle है वो बहुत important है. तो shell model में जो सबसे पहला है, जो सबसे important assumption है, that when I look at one proton or one neutron, then it is surrounded by other nucleons around it. I focus upon only one of the nucleon and I assume that because of all other neighbors, उसका जो average potential है वो more or less same है. ठीक है? So I do not focus upon more than one nucleon at one point of time. I assume that every nucleon is behaving some sort of its own independent potential well. It is behaving, and that potential well is this combined effect of all other nucleon nearby. Hence the name single particle shell model. So this is the first and the most important assumption, that each nucleon moves almost independently in an average central potential VR generated by all other nucleon. I assume central potential as of now. For simplicity, because theta phi agar humne add kar diya, that problem will become more complicated. So I limit myself to only R. I provide a justification also that a nucleon which is deep inside the nucleus is saturated, and because of that saturation we can assume that iska jo average potential hai wo sabka equal contribution hai, and it's fine. The second, which makes much more sense, that Pauli exclusion principle strictly applies, which essentially means that if one particular energy level is filled, then the next nucleons will go to the next energy state. Okay? That makes a lot of sense. Protons and neutrons occupy separate shells. even though they both are nucleons, they are also not same. Protons, for example, are affected by electromagnetic force, neutrons are not. So as a result of that, they have their own separate shells. Okay? Any type of pairing interaction, that is zero. Like whatever pairing interaction leads to जो net angular momentum है, that leads to zero. If one is plus half, one is plus one, another is minus one. So any type of pairing interaction produces J is equal to zero. This is another assumption. Spherical symmetry of mean potential. Right? Again, no dependence upon theta and phi. So it is a central potential. ये वाला पार्ट बाद में आएगा, ये मैंने अभी यहाँ पे लिखा है, but ये पार्ट बाद में आएगा. It started with these many assumptions. Now the next question was that what should be the potential? कौन से potential को हम assume करें और देखते हैं कि हमारा ये problem solve होता है या नहीं होता है. ठीक है? So one of the first potential which was proposed is this potential. Let's assume it is three-dimensional harmonic oscillator potential. अब one-dimensional harmonic oscillator क्या था? That was half omega square x square. यहाँ पे अब x नहीं है, x was just one dimension, this is r. In any other direction I can go, I have a potential towards some sort of restoring point. ये आपको बिल्कुल ही solve नहीं करना है, but अगर आप इस potential से start करो and you solve Schrodinger equation, you get energy level, and this should look very familiar to you. In one-dimensional potential, it was n plus half. Here it was capital N plus 3 by 2. But in the solution, you will find this capital N actually has two quantum numbers. One quantum number is n, another quantum number is l. So, जब आप solve करोगे, you will find that. ये हमको करना नहीं है. इस क्वेश्चन में अगर इसके बाद आपको नहीं पता है कि ये एनर्जी लेवल है, तो फिर आगे कुछ करने का मतलब नहीं है फिर. So n is 2n plus l minus 2, where n is 1, 2, 3, all of that. L is equal to 0, 1, 2, and for every L there are 2L plus 1 ml values. Remember that for every L I have 2L plus 1 ml values. So I have to calculate degeneracy of level n, that if I am at particular n, how many other energy states are possible. And in that degeneracy, these protons and neutrons are filling themselves. And then I have to see that where does a particular shell closes. And if that matches with my magic number, then whatever assumption I have started with, it is correct. Okay? So all combinations of NL giving same n, that is degeneracy, and each L having 2L plus 1 ml values. So let's do that. Let's start with the simplest. And by the way, every ml also has two spin state. Don't forget the spin part. Every ml will also have two spin state. I start with n is equal to 0. If capital N is equal to 0, the only possibility is that small n, L is equal to also 0. And if L is equal to 0, then only 1 ml and 2 spin state. So I have only 2 states possible. Okay. I get my first magic number. First magic number was 2. If n is equal to 1, L is equal to 1, that is the only possibility of dekh lena. I get 6 states. So L is equal to 1, 2L plus 1 ml values, which is 3, 2 spin state, 3 into 2, 6 state. Okay. If n is equal to 2, then I can get L is equal to 0, and that will correspond to a small n, or I can get L is equal to 2, that will correspond to some other small n. But all of them will have that same energy, n plus 3 by 2 h bar omega. So that will produce, if L is equal to 0, that will produce 2 plus 10, total 12 states. So मेरे जो magic numbers हैं, they are 2, 8, 20. Okay, but that's it. After that, if you calculate this, the next magic number will come out to be somewhere around 40, 50, 60. None of the magic numbers are going to match after that. हमारा जो experimental data है, उसके हिसाब से जो magic numbers हैं, they are 2, 8, 20, 28, 50, 82, 126. But this assumption is failing beyond 20. So what do I do then? So then it led to two other introduction. The first introduction was centrifugal term. That if I am into central potential, if you remember your hydrogen atom calculation, you got that L plus 1 by R square term. That was called centrifugal term. When you include that centrifugal term, it does remove some degeneracy. You add that minus h bar L plus 1. इसमें जो कुछ energy states हैं, they further split. जैसे n is equal to 3, that splits into 1f, L is equal to 3, or 2p, which is L is equal to 1, with 1f pushed lower. But that also does not give you all of the magic number. The final correction, that was done by these two people which I have mentioned earlier, Mayer and Janssen. That Mayer and Janssen, I think somewhere in 1948, 1950, they proposed that why are we ignoring this spin-orbit interaction of nucleons? And that spin-orbit interaction is very, very strong. And because of that spin-orbit interaction, that energy level is going to get affected. So he proposed that we have to assume that spin-orbit interaction of proton has orbital angular momentum, has spin angular momentum, so does neutron. We study this for the first time in atomic and molecular physics in the context of electrons. But we use that same knowledge in the context of now protons and neutrons. I have this energy L dot S. For a given L, J will be L plus minus half, that is spin, that L plus minus half. And L dot S, it can be shown, is nothing but half J square minus LS square minus SS square. J square is JJ plus 1, LS square is LL plus 1, SS square is SS plus 1. And if I put J is equal to L plus half, and I already know S is 1 by half, L dot S will come out to be L by 2. And if I put J is equal to L minus half, L dot S will come out to be minus L plus 1 by 2. So this E splits down by V2L by 2, and E pushes up V2L plus 1 by 2. So due to LS coupling, due to that spin orbit coupling, that energy further gets split. And for higher values of L, we can see that ये जो energy split है L plus 1 by 2, for higher values of L, this energy split will be more and more. And as a result of that, we find, I mentioned it here, that for higher values of L, such as 4 or 5, the splitting is so large that J plus 1 by 2 subshell form below n drops compared to n minus 1 level. And इसका पूरा अपना खुद का एक calculation है, I do not have to do it here, but you do that calculation, I have done that in the class if you remember. If you do this calculation, all of the other magic numbers will be reproduced. You will get that 28, 50, 82, 126. By the way, I know for a fact that even that spherical potential जो हमने assume किया था, sorry, that spherical harmonic oscillator जो हमने assume किया था, वो correct नहीं है. But फिर भी with certain corrections, at least we reproduced all of that magic numbers correctly. So that is why जो अगला topic आप पढ़ोगे इसका वो यही होगा कि shell model कहाँ पे successful है और कहाँ पे वो fail करता है, because it does not explain everything well enough. Okay. The next set of question is very easy and surprisingly asked for 15 marks. So that should again make you very happy. Particle physics जब भी आए, we should be very happy, because that will और आपका maths बिल्कुल ही complicated नहीं है. You just have to know very basic things. You have to make few tables. आपका diagram clear होना चाहिए, आपके reactions clear होने चाहिए, आपका presentation clear होना चाहिए, and you are going to get very good marks here. So देखो मेरा diagram presentation उतना अच्छा नहीं होता है, but I have still tried to do the best. So पहला क्वेश्चन देखो क्या है. क्वेश्चन के 3 पार्ट हैं. फर्स्ट पार्ट ये है, explain various leptonic family members. What is the leptonic number? Conservation. Based on this conservation law, tell whether the following reactions are possible or not. दो reaction दे रखा है. Lepton family, we find 3 set of family. The first set of family, there is a charged particle and there is this uncharged particle. For every charged particle, there is a corresponding neutrino. So electron and neutrino. इसको हम assign करते हैं a quantum number Le is equal to +1. Second family, second generation of family, muon and muon neutrino. We assign a quantum number L mu, again +1. And third family, tau and tau neutrino, we assign a quantum number +1. The other 2 quantum number for any of the lepton family will be 0. For electron and electron neutrino, L mu, L tau will be 0. for muon and muon neutrino, Le, L tau will be 0. And every nuclear reaction must follow all of the lepton number conservation. तो जहाँ पे भी आपको lepton दिखता है, you always and always are going to check for lepton number conservation. Because if any of the lepton number is not conserved, then that reaction is forbidden. That reaction is not going to happen. It's as fundamental as charge conservation or mass energy conservation. ठीक है? So let's look at those two reactions. पहला reaction क्या है? Pi meson, which is disintegrating into muon and tau neutrino. Tau antineutrino. बार है. This is antineutrino. जो पाई मेजॉन है वो मेजॉन है. मेजॉन में कोई लेप्टॉन नंबर नहीं है. बट फाइनल स्टेट में आई हैव एल म्यू प्लस 1, एल टाउ माइनस 1. विल दिस बी अलाउड? Every lepton number has to be individually conserved. L mu has to be individually conserved. Le has to be individually conserved. L tau has to be individually conserved. This will not at all be allowed because here two conservation laws are being violated. L mu and L tau, they both are, one is plus 1, another is minus 1. So this reaction is not going to be allowed. I have mentioned it here that this reaction is forbidden as it violates both L mu and अगर एक भी violate होता तब भी ये allowed नहीं होता. But in this case, both of them are being violated. Next question देखो लेकिन ये this is a standard reaction beta decay which we already know it happens. We already know that beta decay happens. I start with neutron. Neutron is not a lepton. Neutron is made of quarks, right? So neutron is made of not a lepton. I start with 0 lepton. Here, the only lepton I have to worry about is that first family. I have electron and I have electron antineutrino. Again, I do not have to worry about proton. Proton is not a lepton. So I start with Le0. L mu L tau तो है ही नहीं, ना तो यहाँ पे है ना तो वहाँ पे है. But look at the final product. Electron का lepton number Le is plus 1. But antineutrino का जो lepton है वो minus 1 है. So I start with 0 and finally 0 plus 1 minus 1 which is also 0. So lepton number जो delta Le है, यहाँ पे 0 है, यहाँ पे 0 है, delta Le 0, lepton number is conserved. जितना lepton से हमने शुरू किया उतना ही lepton हमारे पास बाद में है. So this reaction is allowed. And by the way, I also can check for other things. L mu L tau तो ऐसे भी conserved है ही नहीं, ना LHS में है ना RHS में. Baryon number is conserved, charge is conserved, reaction is allowed. This is very famous beta minus decay. ठीक है? So ये लिखना पड़ेगा आपको सारी चीजें. The last set of question which I am going to discuss, 7A, 7B and 7C. Again, it should make you very very happy when you have questions like this. The first question, 15 नंबर का क्वेश्चन है. ये सिंपल सा बस खाली आपको मल्टीप्लिकेशन आना चाहिए जो कि आपको खुद से नहीं करना है. वो आपके पास कैलकुलेटर है वो. सो यू हैव अ साइंटिफिक कैलकुलेटर, यू हैव टू. बट द थिंग इज दैट यहाँ पे बहुत केयरफुली फिर आप डेटा इनपुट डेटा यूज़ करोगे. खुद से मल्टीप्लाई नहीं करोगे, आप कैलकुलेटर यूज़ करोगे. क्वेश्चन इज व्हाट इज़ द मिनिमम एनर्जी रिक्वायर्ड टू ब्रेक अल्फा, दिस इज नथिंग बट अल्फा, रिमेंबर हेलियम न्यूक्लियस इज नथिंग बट अल्फा, इनटू फ्री प्रोटॉन्स एंड न्यूट्रॉन्स. क्या करेंगे हम? क्या है इसका सोल्यूशन? कैसे करते हैं इस क्वेश्चन को? सिंपल, वी कैलकुलेट द बाइंडिंग एनर्जी. जितना बाइंडिंग एनर्जी है उतना एनर्जी अगर हमने इसको दे दिया, दिस विल डिसइंटीग्रेट. बाइंडिंग एनर्जी कैलकुलेट करने का एक ही तरीका है. आई कैलकुलेट द मास ऑफ इंडिविजुअल प्रोटॉन्स, इंडिविजुअल न्यूट्रॉन्स एंड आई सबट्रैक्ट विथ मास ऑफ दैट हीलियम विच इज गिवन टू मी. इसमें बस एक चीज़ हमको ध्यान रखना पड़ेगा, दैट मास ऑफ हाइड्रोजन दे रखा है एंड मास ऑफ इलेक्ट्रॉन दे रखा है, तो वहाँ से आप मास ऑफ प्रोटॉन अलग से निकालोगे. आई हैव डन दैट हियर. Mass of hydrogen is given, neutron is given, helium is given. Mass of free proton is not given, but mass of hydrogen is given and electron is given. So I simply do that. Hydrogen minus Me, I get mass of proton 1.007 and neutron के केस में it was 1.008. Mass defect हमने निकाल लिया. 2 Mp plus 2 Mn minus mass of helium. Mass defect comes out to be 0.029277 AMU। ये जितना डेसिमल के बाद आप करेक्ट हो सको उतना करेक्ट होने की यहाँ पे कोशिश करोगे। यहाँ पे डू नॉट टेक दैट राउंड ऑफ वैल्यू, डू नॉट मेंशन दिस एज 0.03, ट्राई टू बी एज प्रिसाइज एज पॉसिबल। देयर इज अ रीजन व्हाई दिस वैल्यू इज गिवन। ये डेसिमल कितने आगे तक दे रखा है, अगर क्वेश्चन में दे रखा है डेसिमल कितने आगे तक, तो आंसर में भी डेसिमल के उतने आगे तक का एक्यूरेसी जो है वो एक्सपेक्टेड है। एंड अब यहाँ पे भी देखो AMU में दे रखा है, एंड ये डेटा आपको हमेशा काम आएगा, दैट इफ आई हैव 1 AMU दैट एनर्जी इज 931.5 MeV। तो आप डेल्टा एम आपको पता है, द बाइंडिंग एनर्जी कम्स आउट टू बी 27.28, विच मीन्स दैट इतना एनर्जी अगर हम इसको दे दें तो प्रोटॉन्स न्यूट्रॉन्स दे विल बिकम इंडिपेंडेंट। एक पेज का सोल्यूशन है, 15 मार्क्स क्वेश्चन है, सिर्फ और सिर्फ अरिथमेटिक है, प्लस माइनस एंड मल्टीप्लीकेशन, दैट्स इट। सो ऐसे भी क्वेश्चंस आएंगे आपके पेपर 2 में, वेर यू सिंपली हैव टू डू प्लस एंड माइनस एंड मल्टीप्लीकेशन। अगला क्वेश्चन भी सेम है, बट अगले क्वेश्चन में आपको एक चीज पता होना चाहिए। ये आई विल गिव यू सम टाइम टू सॉल्व दिस, जस्ट टेल मी द अप्रोच कि कैसे क्या करेंगे इसको। कंसिडर अ यूरेनियम न्यूक्लियस, uranium 236, breaking up spontaneously into 2 equal parts. Estimate the reduction of electrostatic energy of the nucleus considering uniform charge distribution. Nuclear radius जो constant R0 है वो दे रखा है 1.2 femtometer, सेंटीमीटर में दे रखा है, मीटर में that will be 1.2 into a to the power 1/3 femtometer। कैसे करेंगे सॉल्व इसको? जस्ट टेल मी द अप्रोच, मेक अ डायग्राम, इनिशियल डायग्राम, फाइनल डायग्राम, एंड टेल मी दैट व्हाट विल बी अप्रोच टू सॉल्विंग दिस क्वेश्चन। एंड इस क्वेश्चन में हमको कोई न्यूक्लियर फिजिक्स नहीं चाहिए, दिस इज अ क्वेश्चन ऑफ इलेक्ट्रिसिटी एंड मैग्नेटिज्म। I do not even have to worry about electrons. I only have to focus upon protons here. You're right. Think more about this. That जो actual question का demand है उसको हम कैसे solve करेंगे? वो एनर्जी क्या होगा? You're right. Before breaking the energy हमको total energy लिखना है, और आफ्टर ब्रेकिंग द एनर्जी हमको टोटल एनर्जी लिखना है। वो एनर्जी क्या होगा? एंड क्वेश्चन में हिंट दे रखा है, लेट मी एम्फसाइज अपॉन द हिंट। व्हाट इज द हिंट? कंसिडरिंग यूनिफॉर्म चार्ज डिस्ट्रीब्यूशन। आप बता दो अब क्या होगा आंसर। इफ अ स्फीयर इज यूनिफॉर्मली चार्ज्ड ऑफ Q, एंड आई एम गोइंग टू एज्यूम हियर दैट वी आर टॉकिंग अबाउट अ स्फीयर, देन डू यू रिमेंबर व्हाट इज द टोटल इलेक्ट्रोस्टैटिक एनर्जी ऑफ दैट स्फीयर? So it is not so total self electrostatic energy. This is a problem which we do in electricity and magnetism classes. अगर आपको नहीं याद है 15 नंबर का क्वेश्चन है तो आप फिर डिराइव कर लो, फिर बनता है 15 नंबर का क्वेश्चन है, डिराइव कर लो। अगर आपको याद है डायरेक्टली यूज करो। ये इतना फेमस रिजल्ट है, सॉरी, अरे अमेजिंग, आपको याद है, दिस इज अमेजिंग, दिस इज एग्जैक्टली करेक्ट। इट इज 3/5 Q/4πε/r। सो आप इसको कैलकुलेट देखो कैसे करते हो। इफ यू रिमेंबर दिस क्वेश्चन आपका ये है, द टोटल सेल्फ एनर्जी ऑफ अ यूनिफॉर्मली चार्ज्ड स्फीयर। हम क्या करेंगे? वी विल सी कि स्फीयर जो है R रेडियस तक बन गया है, एंड उसके बाद फिर हम एक टोटल चार्ज Q यहाँ पे आ चुका है, एंड देन हम dq चार्ज यहाँ पे हम इस तरीके से करेंगे कि ये रेडियस जो है दिस बिकम्स R to R plus dr। ठीक है, इसका पोटेंशियल हमको पता है V, स्फीयर के कारण सरफेस पे पोटेंशियल वी नो, दैट इज V। वर्क डन इन ब्रिंगिंग दैट एक्स्ट्रा चार्ज V इज इक्वल टू V dq, एंड वहाँ से हम इंटीग्रेट करेंगे फ्रॉम 0 टू टोटल चार्ज, एंड वहाँ से हमारा टोटल एनर्जी आएगा, दैट विल कम आउट टू बी 3/5 Q/4πε/r। दैट्स फैंटास्टिक। So if you remember this result, you can directly use it. This is such an important result, you should remember it. And even if you do not remember it, because it is a 15 marker question, derive it. It will hardly take half page of derivation. अब आपको क्या करना है? अब क्वेश्चन बहुत सिंपल हो गया. Q मुझे पता है यहाँ पे क्या होगा, Q विल बी ZE. यहाँ पे Q विल क्या होगा, ZE होगा. एंड R दे रखा है, R इज R0 A to the power 1/3. R0 सेम है, A जो है हाफ हो रहा है, एक में A 236 है, दूसरे में A जो है उसका हाफ है. So I've done this calculation. Let me show you the calculation. पहले तो यूरेनियम का रेडियस 7.42 femtometer. Each fragment atomic number will be 46, atomic mass will be 118, half of that. Self energy of uranium 3/5 Q square by 4 pi epsilon naught, or Q is ZE, so Z square E square, total initial. And final fragment, same calculation, but Z becomes 46 and that R changes, that R is now 5.89 femtometer. ये सब कुछ मैंने SI unit लिया है, so the answer will come out to be into joule. And that is why I have divided that by 1.6 10 to the power minus 13. Minus 19 करता तो EV होता, minus 13 करा मैंने, that becomes MEV, mega electron volt. Calculate that. But ये एक fragment का है, 310. This is one fragment. I have two such fragment. The total electrostatic energy is 621.9. And what was the initial energy? 985. Such a huge reduction in electrostatic energy. And that in fact is an indication that why fission becomes energetically favorable. I write that. Remember, जो भी mathematics करते हैं, we should try to, if there is a physical reasoning behind it, we should write it. I have just mentioned that in one line, that this becomes the driving force of nuclear fission. ठीक है? 5 नंबर का क्वेश्चन है. आइडियली आई थिंक ये 10 नंबर का होना चाहिए, बिकॉज अगर आपको प्रॉपरली करना हो. बट कैन यू अप्रिशिएट दिस क्वेश्चन विदाउट डूइंग एनी मैथमेटिक्स, just with sheer physical reasoning? Can you answer this question yes or no, and whatever the answer is, why? Without going into mathematics part of it. Why it is not possible? न्यूक्लियर फिजिक्स, ये क्वेश्चन देखो यूपीएससी ने यहाँ पे अगेन क्यों पूछा है, इलेक्ट्रॉन फोटोन पे क्वेश्चन न्यूक्लियर फिजिक्स में क्यों है. तो इसका जो बेसिस है वो मॉस बॉर स्पेक्ट्रोस्कोपी है. व्हेन यू डू मॉस बॉर स्पेक्ट्रोस्कोपी, व्हेन यू लुक एट दैट coilless emission of photon, think about this. Even I can justify this physically, that why the answer will be no. The question is saying it is a free electron. Let's assume it is a free electron, and for simplicity let's assume it is at rest. Then it absorbed an electron, and the question is saying that is it possible for photon to transfer all its energy? No, it is not, because even if it is completely absorbed, some of that energy will go into the electron's momentum itself. If you calculate the total energy, let's see this. पूरा मोमेंटम एब्जॉर्व करने के लिए अगर पूरा एक न्यूक्लियस होता, पूरा एटम होता, जिसका जो रिकॉइल है वो मान लेते हैं कि वो करीब करीब 0 है, तो सम एनर्जी विल गो इनटू द मोशन ऑफ द इलेक्ट्रॉन इटसेल्फ. सो इलेक्ट्रॉन कैन नॉट एब्जॉर्व ऑल ऑफ दैट एनर्जी ऑफ द फोटोन. बट आप इसको मैथमेटिकली प्रूव कर सकते हो. आई स्टार्ट विथ an electron with energy h nu, momentum becomes h nu by c, E by c, and then I use conservation of energy. The energy is h nu plus me c square. ठीक है, h nu total, and I am assuming that it has absorbed the total energy. I am going to prove this by contradiction, that I have assumed that it has absorbed total energy. So now the energy has become h nu plus that rest mass energy mec square. But I already know that what should be EE. From special theory of relativity, I already know the momentum energy relationship, that EE should be Pc plus mc square root. ठीक है? And if I take square of that, then I remove that square root. This is Pc whole square plus mc square. So this is, and Pc is nothing but h nu. What was P? H nu by C. So Pc is nothing but H nu. So this is A square plus B square and this is A plus B whole square. अभी मोदी जी बताएंगे कि 2ab क्या हो गया, but यहाँ पे जो 2ab जो 0 है वो पॉसिबल नहीं है, बिकॉज आप देखो 2ab है क्या यहाँ पे, that 2ab is 2h nu MEC square. इसमें कुछ भी 0 नहीं था. When I started my calculation, I assumed that photon has frequency nu, तभी तो उसके पास एनर्जी है. ME is not 0, C is not 0. So this is not allowed. So this becomes a proof by contradiction, because this is not allowed. जो हमने assume किया, the total energy was absorbed. That is also not going to be possible. And the reason is that sum of energy will go into the recoil of electron itself. ठीक है? So electron will essentially move and it will gain that energy because of photon. So bound electron can absorb a photon completely, because जो भी recoil है that is absorbed by the entire atom. An atom is so heavy that we can assume कि it does not move at all. We use this in Morse-Bohr spectroscopy, nuclear physics, and that is why this question was asked, that Morse-Bohr spectroscopy uses this property, that how to make nucleus so heavy that जो हमारा spectroscopy है it becomes recoilless motion of nucleus. Let me discuss the last question. देखो 5 नंबर का क्वेश्चन है. अगर हम खाली फिजिकल रीजनिंग में दे दें जो हम मॉस बावर में करते हैं, तो मेरे हिसाब से कुछ तो नंबर मिलना चाहिए. मैंने पूरा कैलकुलेशन किया है एंड जो मेरा कैलकुलेशन है उसके हिसाब से दिस क्वेश्चन बिकम्स 10 मार्कर क्वेश्चन. अगर आप नो लिखोगे और बताओगे कि कंजर्वेशन ऑफ एनर्जी को वायलेट करेगा, बट आप उसको अगर फिजिकली भी जस्टिफाई कर दो कि कंजर्वेशन ऑफ एनर्जी को क्यों वायलेट करेगा, तो आपको मार्क्स मिलेंगे, कुछ तो मिलेंगे. बट खाली नो लिख दिया और ये लिख दिया कि बिकॉज इट इज़ वायलेशन ऑफ conservation of energy, then you have not proved it, that why is it a violation of conservation of energy. So you have to prove it. अब वो mathematically proof करो या physical justification दो. The best proof will be always mathematical proof, that you mathematically show that this is not possible at all. Okay. Let me discuss the last question. This is a very simple question again. Explain the cause of hysteresis phenomena in ferromagnetic materials. What does the area of hysteresis loop signify? So आपको याद होगा ferromagnetic property के बारे में. We have these magnetic domains, and if I apply magnetic field, Weiss domains इसको हम बोलते हैं. If I apply magnetic field, those domains align. But when you remove the magnetic field, they do not go back to their natural state. So you still are left with that permanent magnetization. तो फाइनली क्वेश्चन में बाकी आप जितना लिखो ना लिखो, ये 2 डायग्राम पक्के से बना के आओगे आप. ये डायग्राम आपको बना के आना है और इस डायग्राम के जो मेन पॉइंट्स हैं आपको बस बताना है. I apply some electric current. This is magnetization versus current diagram, and the same shape you also get into B versus H diagram. I have a ferromagnetic material, let's say iron है, coil से मैंने wrap किया. I apply electric current to it. Magnetization increases. I remove this when electric current is 0, but magnetization is not 0. This is called permanent magnet. I want to make it 0, I have to reverse the direction of the current. It becomes 0 here. I keep again increasing that. All of the dipoles have completely aligned with the magnetic field. Now the poles have completely flipped. So I have another permanent magnet now. And again I do this, I come back to this point. So I get this loop. And that loop, the last part of the question ये है, तो आप पहला part में क्या करोगे, आप इस डायग्राम को एक्सप्लेन करोगे कि डायग्राम में है क्या, क्या लिखा हुआ है. एंड एरिया ऑफ जो लूप है दैट रिप्रेजेंट्स एनर्जी पर यूनिट वॉल्यूम पर यूनिट साइकिल. दिस इज द एनर्जी विच इज बीइंग डिसिपिएटेड, विच इज कॉल्ड हिस्टेरिसिस लॉस. दैट इज व्हाई व्हेन यू मेक मोटर्स और व्हेन यू मेक ट्रांसफॉर्मर्स, यू हैव टू चूज दोज मटेरियल्स जहाँ पे हिस्टेरिसिस लॉस जितना कम हो उतना बेटर है. ठीक है. सो दिस नॉलेज ऑफ हिस्टेरिसिस विल हेल्प अस इन मेकिंग बेटर ट्रांसफॉर्मर्स एंड मोटर्स. दिस इज योर फाइनल कैलकुलेशन. नेक्स्ट सेट ऑफ क्वेश्चन के लिए मेरे पास फ्रैंकली टाइम नहीं मिला अभी आने से पहले, तो मैं अभी आने से पहले ही कर रहा था इसको, बट ये भी इजी है. जैसे इसमें इस साल जो पेपर है वो रिलेटिवली पेपर 2 का जो सेक्शन बी है वो काफ़ी इजी है, सेक्शन ए ज़्यादा टफ है. इसलिए आई ऑलवेज से दिस टू स्टूडेंट कि वी शुड ऑलवेज ट्राई टू फोकस ऑन कंप्लीटिंग दिस सिलेबस. हम हमेशा मन बना के जाते हैं कि सेक्शन ए में हम 3 करेंगे, सेक्शन बी में 2 करेंगे. दैट्स फाइन, but it should also be flexible enough depending upon the composition of the question. And when I discussed this 2025 paper 1, there also I told you कि a good candidate would have attempted 3 questions in paper 1 in section B and 2 in section A, because section A was tougher, but section B it had those like familiar questions. Section A had non-familiar question, and even here also it is the same case that you have some non-familiar, जैसे question number 2 जो हमने देखा, it had some non-familiar question, but यहाँ पे सारे के सारे question करीब familiar है. जैसे ये जो है classify diamagnetic, paramagnetic, ferromagnetic material, and then आपको क्यूरीज लॉ लिखना है, मैग्नेटिक ससेप्टेबिलिटी का रिलेशनशिप क्या है और 1/chi का रिलेशनशिप क्या है ये लिखना है. ठीक है. एक्सरे डिफ्रैक्शन, XRD पैटर्न यूज टू डिटरमिन द क्रिस्टल स्ट्रक्चर ऑफ द मटेरियल. सिंपल सा सेटअप आपको बताना है हम क्या कर रहे हैं. माइक्रो प्रोसेसर अगर आपको नहीं आता, डिस्क्राइब द इंटरनल फंक्शन ऑफ माइक्रो प्रोसेसर विद ब्लॉक डायग्राम. अगेन है बहुत ही सिंपल क्वेश्चन, कुछ भी मैथ्स नहीं है, बस खाली आपको डायग्राम बता के बताना है कि what exactly is happening. And last question जो है thermistor, solar cell, how they are different in structure and operation. 5 marks question है. Again, if you do not know that part, ठीक है, if you have not done electronics, but even then that A and B you should know. So in this paper, a good candidate would have attempted 3 questions in section B and only 2 from section A. And ideally, those 2 questions from section A, I would have picked that question number 3. बिकॉज उसमें सबसे ज़्यादा एटॉमिक एंड मॉलिकुलर फिजिक्स है. मुझे क्वांटम करके कौन सा हीरो बनना है? ऐसा थोड़े कि क्वांटम करके मुझे हीरो बनना है कि बैठ के मैं बढ़िया सा मैथ्स करूंगा. मुझे तो मार्क्स लेके आना है. सो आई विल फोकस अपॉन दोज क्वेश्चंस विच आई नो आई कैन अटेम्प्ट. दे हैव लिमिटेड very less mathematical complexity, and in those 3 hours I will be able to solve those 5 questions. ये हमारा focus होना चाहिए, and that knowledge occurs when you practice more and more. The more you practice, you realize that which type of questions will take how much of time in the actual examination. ठीक है? If you do have doubts, this entire solution I'm going to get it uploaded in this video description, and I will also try to get it uploaded in that previous discussion I took, those 3 questions of section A. I was waiting for the entire solution to do before I get it uploaded, but if you do have doubt, you can send me mail here. All the best, guys.
Your preparation may look complete, but UPSC Prelims 2026 showed something important. Completion is not the same as readiness. The paper did not just test whether aspirant had read a topic, it tested whether they could think through it. Could they eliminate smartly? Could they connect static concepts with current issues? Could they stay calm